statistic, or in this case, the example would be more GPA, is a single number that compresses everything, but it is not perfect. It does not tell the overall story, but it helps us to make a simple comparison from one student to another student. Another example of an average is GDP per capita. You may have learned this in macroeconomics. So GDP per capita simply defines the GDP of a country, how much the output of a country, okay, gross domestic product, divided by the total number of population. But again, it does not tell us the real story. What if, let's say, what if Elon Musk moved to Myanmar? Okay, it is a small country, and it is not one of the rich countries, but once Elon Musk go into that country, the GDP per capita will be very high. Okay, because that only someone. So GDP per capita, it's helpful when we want to know, this country is rich, but it doesn't tell the whole story. So that's statistics. So then what is the use of statistics? If we use descriptive and it doesn't tell us the whole story, you need to look at another number. So if it's your GPA, then I would take a look at how much SKKK that you have earned. Okay, that's one metrics to show how well you perform. Of course, maybe not in academics, but it's a good. Both of them can tell someone what kind of student is this. It can be wrong, but just another number. In terms of GDP per capita, as I said before, if Elon Musk moved to Myanmar, then the GDP per capita will be very high. But another index that we can take a look when we are comparing countries, whether people in there are wealthy enough or not, is the Gini index. Gini index measures how well the wealth is distributed. Okay, so in that one, in the perfect equality, okay, I need to from here. Okay, in this one, in the perfect equality, okay, everyone has an exactly equal weight. Everyone is exactly same, rich, whether they are poor or rich, but it exactly has the same wealth. And in this one, someone is richer than the other, and someone is poorer than the other. Okay, in a perfect inequality, only one person has all the wealth in that country. Okay, so you may take a look into a GDP per capita, but you may, if you want to watch how well is the person in the country, we can take a look as well in the Gini index. Yeah, so what I'm saying is that we may have been using statistics, and statistics is helpful to make us look the data easier, but we have to also understand the statistic is not perfect, especially the descriptive. So we always have to ask another question, or we always have to ask for another measurement, depending on what is the question that you ask. Yeah. Another example. Is it going to rain? What do you think? Yeah. Another example of statistics. When it's dark outside, you say, "Oh no, it's going to rain. I want to go home first." It's not rain yet, but how do you know? Because you know that when it's dark outside or the clouds are very dark, it is going to rain. By experience, it's going to rain. You are sure. This is a probability. You're saying that the probability of raining is very high when the cloud is very dark. But when it's very bright right now, I'll say very little. It's a slim chance that it's gonna rain anytime or in 5 minutes. I don't think so. That's a probability. Yeah. Maybe in a high school. In high school, I got that. But have you ever got an example when you need to flip a coin and then the question asks, okay, so that's a probability. If you flip a coin, but in statistics, you need to clarify whether the coin is fair or not. Okay, because if it's not fair, let's say the coin is not fair and it ends on tail most of the time, it's not a fair coin. But if it's a fair coin, we know that the probability that if you toss a coin up, the probability of head and tails are 50-50. Yeah, so that's statistics. Okay, when should you get your next vaccine? Have you got your booster? Not yet. Okay, so in here we see, yeah, how do these people or the researchers or government say that it's best that you get the next dose in 6 months? How do they know? Because they have collected a samples of people who have taken, in here I see they're divided in terms of like what is the type, the brand of the vaccine and where is it where the study was. Okay, so we have two Pfizer in here, and one is in the US and one is in Canadian. Do they test the entire population of in the US? I don't think so. And Canadian, I don't think so. Canada is much smaller than US, but I don't think that this study takes the entire population. So what do the researchers do? They take some sample of people who have been taken the Pfizer. Okay, and then they will, let's say they test how high is the antibody over time. Let's see in here, I think they tested every 2 weeks, okay, or 2.5 weeks. Okay, and then test and the test. And then this is the result, and it shows that the effectiveness of the vaccine wanes after average 6 months. And that is why, you know, we should get our next dose in 6 months. This for COVID, of course. Other disease may have a different behavior. Okay. Now, so this is statistics. Statistics help us to answer questions like this. Do you think smoking causes cancer? Some people say yes. And if you go through Siwalan Kerto, like after High Point, and then you turn left, right in front of you, there is like a big billboard in which, you know, you see like a man's throat, and it's yeah. Okay, so it's saying that smoking is not a good, but how can they claim that smoking is not good from research? And how do they know? They have been tested it. Okay, that's statistics. All of you watch movie, yeah? And maybe many of you watch Netflix. I watch Netflix and I like it. And I think after like 3 or 4 years using it, Netflix is getting so much better at knowing what movies will I like. Do you agree? How does Netflix know? Yes, from research. And well, let me just, I watch Friends. I'm old. I watch Friends, and I'm the Big Bang Theory, okay? So Netflix will show me, Netflix will look at their data and see people who watch Friends most likely watch what else. If you give feedback to Netflix, it will get to know you even better. Feedback means if you put some movies in your list, or if you give a thumbs up or thumbs down in any movie that you have watched, you know, it gets to know you even better. So we call this business analytics. It's called recommendation system. It is the same system behind Tokopedia or Shopee. You know, after you browse some products, oh, I needed this one, okay, because you have purchased a product that is related to this one. Okay, so how does Tokopedia know that? Using a recommendation system, and behind recommendation system is statistics. Okay. Okay. Do you like to watch criminal movie? I like CSI. I like Criminal Minds. And for CSI, if you ever watch it, what they do is they will take DNA samples in the crime scene, DNA samples that does not belong to the victim. Okay, so let's say, oh, ada rambut di gelas. And then they will take the hair, and then they will take it in their lab and check for the DNA, and then you will check the DNA match across the database. And that is also statistic. It says that a DNA match of 2% is 1 in 113 billion. It's so unlikely. So if there's someone DNA in the crime scene, most likely that someone was in this crime scene. Also statistics. Some questions. Do you think rich people live longer? No. According to the data, this is the bubbles are the countries, and the size of the bubble shows how big is the population. And then sorry, yeah, I have to show here. Sorry guys, the one online. And then, so the size of the bubbles shows the size of the population. Okay, so you see one of the big bubbles here is China, and then the other one is India, and Indonesia is somewhere around here. Okay, and then on the x-axis is the income per capita. Okay, and this one is the average lifespan of people who live in that country. And you see from here, okay, the more we go to the right, it means the richer the country is, or GDP per capita, the higher the lifespan. And from this data, kelihatan ya, ini kayaknya semakin ke kanan dia rapi ya ke atas. There are some data that is off. For example, this this country in here, gets very small, and it's quite rich, okay, because the income per capita is almost 50,000, yeah, but then a very low lifespan. Okay, so this is off, but on average, if you see from here, you can almost see that it is a straight line going up to the right. Yeah, so the answer, see from this one, and actually that is the answer. Rich people tend to live longer. Yeah, so I hope I have convinced you that you may have using statistics in your daily life, and that when you become a businessman or professionals, you also need to know the underlying working of statistics. You will not be a statistician, but at least you know that statistics contributes a lot in the business. In fact, this data analytics or business analytics is one of the hot area right now. It is one of the area in which person who work in business analytics get the highest salary. Okay, and why is it now so booming? Because data is everywhere. Each click that you make in your Chrome is captured by someone, at least by Google. At least by Google. Google knows what pages have you visited. Google knows that you probably a male or female, whether you are a teenager or whether you are a working mom, Google knows about that because of the pages that you visited. And it's a vast amount of data. If you click Tokopedia, every page that you click is captured, and they try to understand you. So there's just a lot of data out there and very little scientists to make meaning from this data. Yeah, so it's why it's booming, and why it is very, very important. And in fact, we think that understanding of statistics plus analytics is very critical to management or business students. Okay, so we have seen some examples, and we see from here that business statistics provide a formal basis to summarize and visualize the data. We see summarized data, GPA, GDP per capita, and visualize, we see the graph with rich people tend to live longer. Okay, and then we can also reach conclusions from business data. We can make reliable predictions, just like Netflix bet that you will like the next movie that you see in your Netflix. Yeah, make a predictions and improve business process. Okay, for the one online, if you anytime lose my voice, just but you need to shout. I will not see you. I will not see if you raise hand or chat, or you can text Martin. Okay, but the most important thing that I sincerely hope that you will do after taking statistics is that you can be critical about any data that is presented to you. You need to be critical and do not simply or take everything just at face value. No, you need to, okay, so your GPA is 3.9. And where did you go for study? Kalau dia bilang di Harvard ya, oh yeah. Well, but that is a question that you can ask. Okay, for example, this one. This person asked, okay, so if I join your company, what would my starting salary be? Okay, and then, the guy said, well, let me put it this way, that on average, the starting salary is 80,000. But what is the flaw in that statement? Will you question that one? And if you hear the average salary is 80,000, what question will you ask? Anyone? Will you think that your salary will be 80,000? But why? That's only the average. Yes, that's correct. And then in real life, we say average, but in statistics, there are three types of average. That is the average, the mean, that is the arithmetic mean. And then the median, that is the one data point that divides the entire data into two equal sides. And then mode, it is one of the data point that, or the value that occurs most often. So when they say average, what do you mean by average? Most people say average, meaning the arithmetic average. And for this one, okay, for this one, let's say they are let's say there are 5% there, and then the CEO has 300,000, and the rest has 25. Okay, and then there are 5% in here. So yeah, he was not wrong. He's just misled people. So it will be 400K divided by 5, which is 80,000. But there's only one person who got 280,000. Most of the employee got 25,000, but he was not wrong. And this is all about statistics. You know, you can actually mislead people and not be wrong about it. Yes. If you crunch that number into your calculator, you will get 80,000. That's correct. But it misleads people. Okay. Now, another example. These two are exactly the same data. What is the difference? Exactly same data, but presented differently. The left one has more detail, okay, and the right one? Should be more precise. So which one do you think is the correct one? The left or the left? Okay, the right one is the right one.
One on the right. Oh.
The one on the right is right. As a rule of thumb, you always have to start the axis with 0. That's a rule of thumb. Okay. So and then let's see what data is this. This is interest rate in percentage. And then in here, the difference between one row to another is 0.002%. It's so small. So we can say actually there is no change in interest rate. But then you can graph it in other way so that people say, wah interest rate kita naik nih, nggak benar nih pemerintah. See what I mean? Is the data wrong? No, the data is not wrong. So that's why I hope that when whatever business that you are in, the next time when you are presented with data, just be critical about it. Just think further. Okay? Bias in a sample. This is a researcher. Okay, this is a researcher. And then the researcher want to know if let's say the question is whether people love cats or dogs more. But then what does the researcher do? He goes to a dog pigeon. What do you think the answer of the people there will say? Oh, of course they like dogs. That's why they are there in the first place, right? So that's bias. This is bias. So I have a very interesting question from my lecture before. It says that, let's say IBM has a budget that we can improve one of the facility. There are two options: is whether we can improve our dining, student lounge, or dining room. Okay, we can improve the facilities, or we improve the library. Okay. So what will the students say? Okay, that depends. What do I want? What I want your answer be. If I want you to vote for dining room, I will ask you slightly before lunch, because food is all you can think about. Okay. If I want you to vote for library, I will ask you slightly before exam. Okay. So that's with statistics. It's not the number that is difficult. The design of the study to make sure that there is no bias. So if I want to ask you that question, when should I ask you? That is the design. I have to design it, because your result, once I get your result, I just need to, put it in SPSS and it will give me any, the number. Yeah, so that's statistics. Then another example is that sometimes people say, oh, iya nih, satu naik. So for example, in this, during March, May, and during May to July, there's a strikingly, same pattern in shark attacks and ice cream sold. Both are increasing. And if you crunch these two numbers into SPSS, they will say that they correlate. Because they happen to know to go up in the same time, and then even the slope is similar. Okay, so SPSS will say that there is a correlation between, yes, does it make sense? So again, we need to, look into the data, whether it makes sense, because there are so many data in this world, and if you just by chance put them all together, you will see correlation in many things. Yeah. Another pitfalls is like causation, that A causes B. So when we say it correlates, we only say that they have a relationship, but we are not sure whether one causes the other, okay, or there is no cause effect at all. So correlation does not always mean causation. In fact, causation is very hard to prove. It needs a design experiment. Contohnya kayak gini, I used taxi before, I used Grab, and then because we both have kids, it was a long trip, and then he said something like this. Saya itu Bu, saya rasa anak-anak itu nggak perlu lah terlalu bersih-bersih. Nanti badannya jadi lemah, nggak pernah kena kuman. Biar aja mereka makan yang kotor-kotor sekali-sekali, sakit sedikit, kan antibodinya naik. Benar Bu, saya lihat saudara-saudara saya itu ya, yang istrinya tuh bersih, makanannya harus ini tuh anaknya pada suka sakit. Jadi dia bilang, he said that if a mother is too clean, anaknya jadi gampang sakit. Oke? Tapi kalau kita pikir, masuk akal nggak sih? Mungkin ya ada penjelasannya kan? Tapi bagaimana kalau kita balik? Bagaimana kalau ibunya terpaksa bersih karena anaknya suka sakit? Nah, bisa dimengerti? Kita nggak tahu apa yang menyebabkan apa. Jadi walaupun ada korelasi antara anak yang sakit dan ibu yang bersih, mungkin ada korelasi. Belum tentu A causes B or B causes A. And to prove that needs a design experiment. That's all I'm saying. I mean, like if someone claims that to you, you need to be critical. Oh ya, emangnya risetnya gimana dibuat? Ya. Okay, so we go back from here. Yeah, this book, the book that we're using is they use like the COPA. It stands for define, collect,